Hello, welcome to Tom's Hardware, the podcast, and it is July the 2nd. Wow. Tonight we have a very special guest. We've got Pieter from SkatterBencher on the show tonight, and this is a project I saw online. I was just like, why didn't I think of that? It's one of the projects that for Raspberry Pis, and now we've got these really powerful Raspberry Pi 5s, we all should be using stuff like this to, benchmark our Pis. But rather than me prattle on about it, I want Pieter to discuss it. So, Pieter, the floor is yours, sir. Tell us all about yourself and anything else you want to talk about, and SkatterBencher.
Well, thank you very much for inviting me to the show. I'm always happy to talk to fellow enthusiasts, whether that's PC DIY, overclocking Intel and AMD CPUs, or indeed overclocking single board computers like the Raspberry Pi 5. I was a little bit surprised to get the invitation, to be honest, because I'm not really a, let's say, Raspberry Pi diehard enthusiast. I bought the very first one and I tried overclocking it as well, and I wrote a little guide about that. But then I skipped 2, 3, 4, and then just saw the Raspberry 5, Raspberry Pi 5 came out, and I said, okay, fine, I'll have a look at that and see if it can overclock. So on my YouTube channel, SkatterBencher, and also on my blog, I try to post these overclocking guides for people who want to get into overclocking, and I try to be, as comprehensive as possible without overwhelming people with too much technical details. Although sometimes you need to get a little bit technical to really understand what's going on. And so my plan was to do the same with the Raspberry Pi, and with Intel platforms, AMD platforms, I kind of know already what to expect whenever I start a new platform because I'm very familiar with their overclocking technologies. But with the Raspberry Pi, I really started from scratch, and so one of the key things that I do in my overclocking guides is that I always have a stability test at the end of every overclocking strategy. So an overclocking strategy is essentially, it consists of having a certain amount of changes to the BIOS or to the frequency and voltage configuration. Then I run a bunch of benchmarks to check the performance improvement. And I always include also a stability test, because the point is that I show people, here's the settings that I used that were stable and gave me this amount of performance improvement. It's important for me to see that stability test, because it gives me information on where are there some bottlenecks, or where are there some performance tuning opportunities. So very, very often a performance bottleneck would be temperature related, or it would be a power limit, or it would be an electrical limit, and so on. So I want to do the same process with the Raspberry Pi 5, but I kind of ran into an issue that there isn't really this one tool available that will give me frequency limitations and voltage limitations and telemetry from the PMIC to sort of have an understanding of what's going on during my stress test. So I wanted to figure out, okay, how can I build this tool? And so browsed around, saw a lot of information coming from what's his name? Jeff Geerling, I think, is very active in sort of sharing how to get the most out of your Raspberry Pi. There's also a bunch of forums and some GitHub discussions where some of the commands are being shared. And then I said, okay, let me just collect all of the relevant commands for frequency, voltage, and any other telemetry, and put that in a Python script that I can run side by side my stress test, as well as log out to CSV. On regular desktop systems, I would always use hardware info for this, but in this case, I had to kind of build my own script. And then it took me, I think, a day and a half to kind of collaborate with Copilot and ChatGPT to make the script work, because I don't really know how to code myself. And then I shared it on Twitter, and then apparently there's more than just me who kind of thinks this is pretty cool.
It is really cool. So I wrote a very basic version of your script a few months back. I mean, very basic, just CPU frequency and temperature. That was it over time. What you've done is log everything that you need to know about a Pi 5 in this case. So the PMIC voltages and temperatures of the CPU, the GPU, everything. And it's all updated in real time in the bash shell, so you can see what's going on. But then we get this wonderful CSV file. Now, being someone that benchmarks Pis all the time, it's wonderful for me because I can then take that CSV file, dump into Google Sheets, and there we go. Just search through it for the temperatures for the CPU and the processor speeds, that sort of thing, and it makes my job really easy. So thank you. That's great. But you mentioned you did it with Copilot and AI, and you're not much of a coder. For not much of a coder, you've done exceptionally well with this piece of code because it just worked beautifully. So how did Copilot and AI help you to write this code? Was it an easy way you just said, write me a script that does this, or was there a bit of back and forth where you had to interact with what you got back from Copilot and to make it better?
Definitely a back and forth. I can't remember exactly how, like, what was sort of the first output. I think I started with the VC gen commands for. You have the measure clock, measure volts, measure temp, and essentially, put into the AI, say, this is my command that I want to read out in a terminal. Write me a Python script, and then it makes the basic Python script. So it imports the libraries that it needs, and it puts sort of the basic script together, and then you kind of slowly build on top of that. So once you have one thing working, then you can say, okay, now I also want to add in, checking what the CPU usage is, for example. And I think the most interesting one that I found was the function to decode the throttling, because it's a little bit more complex than just reading out one line. And like, honestly, this code, I would not be able to write that myself. But you sometimes you get an error message out of it, when you actually try to launch the script, and then you throw that back into the AI and say, hey, this is the error that I get now. Sometimes you have to kind of nudge it along and say, oh, I get this error and it's probably related to this particular line, and then the AI will sort of acknowledge and say, yes, okay, I understand, here's the new updated code. And yeah, that's also why the script name is, I think it's something like telemetry works. I have a whole bunch of scripts where it doesn't say works.
Awesome. I'm just looking through the code now. I've got it soloed on screen so everyone can see it. So you've got field names. You're covering every single base of what we need for benchmarking. So we've got a timestamp. Obviously, we need to know what time it's recorded. CPU percentages, ARM processor speeds, even the speed of the GPU, the H.264 decoding, V3D, UART. I mean, we don't really sit there and think, I need to know the speed at which my UART is running, but we've got those details now. SD-RAM voltages, all the general voltages on the board as well, because the Pi's got 1.1 and 3.3 and also a 5-volt rail. If memory serves, we're probably wrong on one of those. Or there's a 0.8 as well. I can see that in the script. And also you mentioned the throttle hex. Yeah, that's right. When you're using VCG-EN command, I'm going to say VCG from now on for easiness, it does return some details, say if it's throttled or not, and it is a hex value. So decoding it is fantastic because it just means it's a lot easier than me having to work out what does that mean? What does this hex value mean now? What I've got it ready to go. So
yeah,
go ahead.
That hex value is interesting because it's not just a matter of, let's say, decoding the hex value. Actually, you need to know what bit is flipped within that. Like, you need to go from hex to binary and then check which of the bits is 1 or 0, and then you can kind of figure out what's going on.
That is very cool. So is this version, can we say, is it version 1 or is this version 0 point something, or?
I think this is version works B, maybe. There's still a couple of things that I wanted to add in there as well. I believe there's one, there's a read MR command as well that has some, I saw on one of the GitHub discussion threads, there's some information related to the embedded memory chip status. Maybe it's like refresh cycle or something like that. So that's something that's still missing from it. I did also see when looking through the boot main code that there might be some other commands that are maybe not publicly documented that might be relevant for that. So it's by no means it's like a finished final product, but it works for now, so it's good enough.
Where do you see it going as a project? Is it going to be updated with some new features? Have you got any new features in mind or extra features you could put in?
So where I'm at right now, in how shall I say, like my project for the Raspberry Pi is very much trying to get to a point where I can write a SkatterBencher guide. I've reached a point now where I think the low-hanging fruit for overclocking is kind of covered, and that's really the basic. You add the overclocking commands to your config.txt. You play around a little bit with the overvoltage delta, which is actually kind of cool. You can do undervolting, overvolting. You can do a fixed line. So there's kind of an advanced way of managing your dynamic voltage frequency curve. The step after that is the figuring out the voltage limitations. So I'm not sure if you may remember that in the very beginning when Raspberry Pi 5 was launched, there was a frequency limit to 3 gigahertz, which then was resolved by kind of an update to the firmware. Now you can set over 3 gigahertz, but there's still a voltage limit. So no matter how much over voltage delta you try to give to your Raspberry Pi 5, there's actually a 1 volt limit for the core voltage. So I've been trying to figure out what's going on there. There's I think his nickname is Jonatron. I don't recall exactly, but he figured out that you can extract the firmware from the official firmware, essentially pull it apart, and then you can analyze the boot main, and in that code there's a function that actually defines the voltage limit that you can request through your dynamic voltage frequency curve, and you can as a root user on Linux, you can overwrite that. So that's what I've done so far. I can set essentially any voltage that I want.
Wow!
In the sense that the voltage is still requested by the SoC to the PMIC controller, and so the next challenge that I'm trying to resolve now is there's actually a voltage limit on the PMIC side as well. So even if you can have the SoC request 1.2 volts, the PMIC will only output 1.1 volts. So you get a bit 100 millivolts extra, but not yet fully unleashed. So the next step is to try and figure that out.
That is very cool. I did not know you could do that. That's interesting because I've managed to overclock a Pi 5 to, I think, 3.1 something gigahertz. This is after the firmware update recently. Before that, I got 3.1 on a pre-firmware update Pi, but it wasn't very stable. I did try for 3.2 on the new firmware, and even after changing the delta a little bit, it still didn't give me consistently good results. It kept crashing. In fact, I was using the Sunfounder Pioneerman 5 case, which I got over there, just out of reach, to keep it cool, and it just would not stay stable. So it's interesting that what you say, that's something I need to dig into and have a play with. What's the fastest you've managed to get a Pi 5 so far?
So far, I think 3 gigahertz fully stable in S2E is the stress test that I use.
Yeah.
And it doesn't throttle with an extra fan on the heatsink. And awesome. I think it was about 2.9 gigahertz with 1 volt. So not the best sample, that's for sure.
No, the silicon gods have not looked on you favorably for that one, but
unfortunately,
yeah. The model I got, the first one I got from Raspberry Pi for the review, I managed to get 3 on. Wow. That was just using the standard here it is, in fact, in front of me, using the standard active cooler. I got 3, and it was pretty cool. But then when you've got stupid things like I got behind me, we've got the water cooling kit from 52 Pi, $120 kit, which keeps the Pi absolutely freezing cold, but it's just huge.
It's, this one here. I bought just the water block. Yeah.
Really, pardon the pun, but it is really cool to look at. When it's just a huge piece of metal keeping your Pi cool. But I haven't got it to hand, unfortunately. So I can't show. Oh, yes, I have. It's here. I've been playing around with this one from 52 Pi, the Ice Tower Plus.
Wait, hold on.
This is where we start comparing fans and cooling, isn't it?
Let's see if I can unplug it all here.
But it's just amazing what you can get now for about $20 to keep your Pi 5 cool.
Yeah, and honestly, I've had a lot of fun playing around with the Pi 5 so far. Yeah, here we go. I think it's the same ice cooler.
That's yes. I can. Let me just bring the solo on that. That one is this one. Now you can't see it because I just soloed you. You think after 180 something shows, I know what I'm doing. It's that one, but this one.
Oh, okay. I need to upgrade my cooling.
That's about $20. That one. Immensely powerful cooling, and the fan is very quiet because it's large. It's a 60mm fan, if memory serves. You've got an aluminium base to it as well. So your Pi 5 sits on that.
Oh, yeah.
In the middle. There you go. Whereas the other version that you've got there, it has an acrylic base, so there's no cooling apart from it's got a vented bottom, so to speak.
Yeah.
That the air can pass out. Not impressive.
This one does fine with up to 1 volts. I don't really have any overheating issues. Yeah. But then when I put it to 1.1 volts, then all of a sudden there's a little bit of throttling going on. So I just have to. Actually, I use this. It's kind of a cool little thing. I use this one here. I'm not sure if you can see it.
Let me just solo that.
There you go.
Oh, I've not come across that. Tell me more about that. That's interesting.
It's so Elmore Labs is a company that's run by a good friend of mine here in Taiwan. He specializes kind of in PMD, so like power measurement device for PC DIY. But this is it's called a UPF, and essentially it's so you have a 4-pin fan on the one side and then a Type C on the other side. So it's kind of easy to have a regular PC fan on the Pi here. All you need to do is connect it to a Type C. Otherwise, you would need to connect it to kind of a live PC. So
that's very cool. So we talked a lot about the Pi 5. That's obviously the new flagship Pi. And you mentioned that you had originally the first Raspberry Pi. Have you tested your script on the original Raspberry Pi? Does it still work okay?
I have not looked at it. Actually, I just found it this morning in one of my boxes. So maybe later this week I'll have a look if the script still works.
That'd be interesting. If it could work on all Pis. I mean, Pi 4 onwards is where we start getting the really hot Pis that need cooling. But before that, 3, 2, 1, they were all okay. They didn't need much cooling. It'd be interesting to see if it would work, or if it could be changed in some way so it would work on all Pis, because you're really using the VCG ENCMD, that's a mouthful, commands to interrogate the system. Is that something that Copilot said to use, or is something that you already knew, or something else?
I started using it because when Jeff Geerling made his video, he was kind of pointing out some people hit like 3.1 gigahertz, but it's actually only 3 gigahertz, and the only way that you could really detect it is this VCGen command tool. So I was like, okay, I'll just use the tool that gives the accurate information.
Yeah, completely true. I had that conversation with Gordon from Raspberry Pi Limited back end of last year when the Pi 5 was just about to come out. We wanted to accurately record the Pi's CPU speed and temperature. And we saw guides on the internet that were saying, oh, use this tool and you can overclock to 3.4 gigahertz or something daft like that. And it turns out it was reading a config file in the boot partition, which just said, you said your overclock speed is 3.4. And then the tool that they were using to measure the stress tests and the temperatures in the CPU was just reading that config file and going, oh, right, 3.4 gigahertz. It wasn't doing anything with VCG. So that's why when we had an initial conversation, I asked if you're using VCG. I was elated to find out you were, because you just solved the problem straight away without ever encountering it.
It's actually a very common kind of a problem in let's say PC overclocking as well. I was part of the team that also did the 9 gigahertz on Helium, and so one of the issues we had was also detecting what's the actual real frequency, because there's a difference between configuring your clock generator or your PLL to run a certain frequency and the CPU cores actually running at that frequency. There's a whole bunch of frequency throttling technologies that are embedded in these CPUs that can prevent you from actually running at the frequency that you tell it to run at. So, again, it goes back to what I mentioned in the beginning, that for my guides, I want to have this reliable information about what's going on the system, where I usually use hardware info, and with the Raspberry Pi, I kind of had to figure out what's a good way to do it.
Yeah, definitely. So obviously, this tool is still work in progress. We've talked about some features already. Do you think there could be a GUI version, some like hardware info, so it has a nice user interface for those of us that aren't terminal wizards?
The code is on GitHub, so anyone who wants to use it can make a GUI.
Awesome. In fact, I'll just put that code up on the screen so people can go there. It's also in the chat if anyone wants to have a look at it. I've had a look through it and really well done. So really impressed with it, and it just works, as I say. And the output for the CSV file at the end, nice and easy to work with. Drop it into Google Sheets, Excel, whatever you use for your spreadsheets, and away you go. So really impressed with that.
Thank you. I think the next step for the project is I kind of already showed it a little bit on the stream. Maybe you can see it here on the back. So there's some cables soldered to the back of the Pi here. So these are the test points that it's the I2C points for the PMIC. So it's possible to talk directly to the PMIC and configure some voltages, or at the very least, like read out some voltages of the PMIC configuration as well. So that's part of the journey to try and get above this 1.1 volt limit.
Awesome. Now you've got me looking at the back of a Pi 5 to work out which test points they are. I'm guessing TP8 or TP15, something like that.
40 and 41.
My hopes were dashed. Oh well. Oh yeah, I can see them. Very cool. I knew about the test points. Didn't know they were there for the PMIC. That's handy to know. So how did you find those? Were you pouring through schematics, or did someone tell you they were there?
I'm not sure if there are schematics available for the Raspberry Pi 5, like the electrical schematics.
No.
So again, I went to my friend's office, Elmo Labs, and so I had my Python script running, which pings the PMIC quite often, and we were just looking at all of the test points if we could find something that resembles I2C data bus and clock. So then these 2 points kind of looked like I2C signal, and one of the data test point, you'll see that when you enable the script, it's very busy, and then when you disable the script, it's a lot less busy. So that's how you could kind of narrow down, okay, these should probably be I2C connections. And then we can use his EVC2 tool to hook it up, and then just check if there's any address, and then then you can start running the commands on it.
That's very cool. Have you got a background in electronics or computer science? 'Cause it sounds like you know your stuff. But you said that you can't program, but it seems like you're an intelligent person.
Thank you very much. No, I did my bachelor's in psychology, and I have an MBA. So everything related to computers is just from being an enthusiast since I was a young teenager, and then sticking around and just learning by doing.
Awesome. So, what was your first computer then? We'll compare computers now.
The first one that I built myself was the Athlon XP 2600 plus Barton core.
Wow. Oh, Barton core. Yeah, I remember those.
Yeah. Ooh. And I foolishly bought a motherboard that had 4 DIMM slots, or 3 DIMM slots, and I only needed 2. And then with 2, you could get higher frequencies or something like that.
Yeah.
I bought one with a VIA chipset, and the issue for overclocking was that the front side bus was linked to the PCIe, or to the PCI bus. Sorry.
Okay.
So I had a limited range of FSB overclocking.
Wow. The first one that I made from scratch was a K62 400 with 128 meg of RAM, and I think I might be wrong on it. It's a 40 gig hard drive, or it could be smaller than that.
More than you'll ever need.
Plenty, yeah. But the first ever computer I had was a Commodore 16. That was 1984, 5, I think, when I got that. And I quickly upgraded to a Commodore 64 after that, because there wasn't many games for the Commodore 16, and I wanted more games.
Was that with cassette tapes or
yes.
floppy?
Yeah.
Yeah. My dad had a BBC. Is that possible?
BBC Micro, yeah.
Yeah, and that was also, you had to use a cassette tape and then play the cassette tape and then boot up your system and then wait for 2 minutes.
Yeah, that was it. Is it handy? No, it's not. I'll destroy my shelf and try and take it off there. But yeah, cassette tapes were the main way to load, software in the 1980s and some of the early 90s. Especially for Commodore users and BBC, because floppy disk drives were hideously expensive. 1541, which is the main floppy drive for Commodore 64, it's probably the same price as the computer.
Wow.
So, okay. And that was really expensive. But we digress heavily on that because of old computers, but it's interesting to know about the past. But we're going to look at something else that's from the past now. And it's as if I planned the segue. I didn't actually, but as if I did. Floppy disks. If you watched the show last week, you remember that I was building something based on a floppy disk. And now Peter's thinking, what? So I'm just going to switch over to my overhead camera once I close 17 windows. There we go. There is a floppy disk. It's not a real floppy disk. It's 3D printed. The exact measurements of a floppy disk. And last week, you would have heard me say I was building a project to have the latest Tom's Hardware headlines appear on an e-ink display in a 3D printed floppy disk. And here is the project. So that is the latest headline from Tom's Hardware. Let's get it the right way around and in shot. There we go. That's the latest headline we've got. And if I just set the focus, there we go. You can see there's a QR code. I've still got a bug on that, unfortunately. And around the back is a Raspberry Pi Pico W, which is driving the display and also connecting online to get the data for the news headlines. It generates a QR code there, which you can scan with your phone. It takes you straight to the headline. We've got a really big LiPo battery, 2000 milliamp, and we've got a LiPo Amigo charge controller there. Let's just set the focus again. So that is providing power to the Pico via this battery, but I can also charge the battery via USB-C and keep this thing topped up. So when I'm at a conference, I can wear this badge and show people the latest news headlines and who I am. And it's an upgrade from the previous one I had, which was this one. Let's get that in shot. where if you wanted to get a QR code for just my stories on the site, you press that button. So this project here, the floppy disk, will be on Tom's Hardware very soon, probably this weekend. So you can build your own, all the code, all the links to the 3D files that I use for this, and how I cut the file apart to put bits and pieces inside it, and links to all the components and where you can buy them, will be on this weekend. See, I told you I'd get it done, and I got it done. I just can't use this StreamYard. So let's get my face back on. There we go. So that was a good segue with floppy disks. Thank you.
That's awesome. Very cool project.
Thank
See,
you.
I would not be able to do that at all.
Literally, the floppy disk that I used was on printables, and all I did was put it in Tinkercad and cut a hole. In fact, I've got a one that I printed. It got the dimensions wrong. So that's not a floppy disk size, is it? Really? That's wrong. Cut a hole in it so that the screen can go on the front, and then the Pico goes on the back, and the two sandwiched together to hold it all in place. And then the batteries are. Go on.
That's 3D printed.
Yeah.
Oh, cool.
Yeah. An Elegoo Neptune 3 Pro is just over there, which was one of our editor's choice 3D printers from 2022, if memory serves. There's now a newer version, the number 4, Elegoo Neptune Pro 4, which is a lot faster. But that one does the job really well. But yeah, there'll be a guide this weekend so you can build your own and have some fun with that. And it was good fun to build. There was a few moments where it was infuriating because I wrote the Python code for this and it should have worked, but then it failed. And that bug with the QR code, I still can't work out. But someone cleverer than me will probably work that out in seconds.
Have you tried asking Copilot? It worked for me.
I have asked ChatGPT, yeah, but it wasn't any help, unfortunately. But good thinking there. It's something to do with, because the headline we've got here, that's the headline straight from the site. It's quite a long headline, it's quite descriptive. So I'm thinking it could be the density of that headline is now transferred to QR code. Of course, more data in the headline, the denser the QR code. And because of the boundaries that it has on the screen, it says, oh, I can't make it too big, so it'll crash into the words. So work in progress on that. We'll get it fixed. There's the code's on GitHub, so people can tear it apart and see how it works.
Do you ever feel a sense of I wouldn't say shame or embarrassment, but that's what I felt when he said, "Oh, can you share the code?" I was like, "Oh, I don't know if I'm ready to show." It feels like I'm showing someone a really poor drawing. It's like, well, this is not good.
No, I completely understand that. I've been in situations like that where I've had to show my code, and it hasn't been the best code in the world. But if you're in the right environment that's supportive, so they're not there to heckle or to cause any mischief. If they're there to help you, then show it and you'll learn. So yeah. I used to do training with Raspberry Pi Foundation for Pi Academy, and I was one of the trainers. And I would write some code on the screen and show it to everyone in the room, and we'd build robots and do really cool things. And then one day, a person came up to me and said, you can do this differently. And it's just how we imported lines of code. So we do import time, imports, sub-process, OS, that sort of thing. And they said, you can do it all on one line. It's not part of the Python guidelines for how you write code, but it just means you've got a lot shorter code. I was like, okay, that's really cool. So I'll give that a go. Obviously, the inverse of that is someone would say to me, you shouldn't really do that because it's not in the Python guidelines. But it's all feedback and it's all knowledge at the end of the day. But I've got Sir Pirate in the chat and he just says he remembers using floppy disks to install Windows 3.1. Yes, completely remember that. Yeah. I remember installing DOS 622 on a 486 DX33 in 1990 something. I was only a teenager. Then having to install Windows on top of that. Yeah, that was mad times. In fact, I did a FreeDOS install about 2 weeks ago because I wanted to emulate a Scion PDA, and the emulator for that wouldn't work. Wouldn't work on modern Windows machines. So I think the limit it hit was about Windows XP, and it would just go no after that. So it, spoiler alert, it didn't work. So I just installed DOSBox and did it that way. It was easier. But that worked for me.
A good trivia question is how many floppy disks did you need to use to install Windows 3.11?
See, I didn't have 3.11. I had 3.1, and I'm sure 3.1 was 3 floppy disks. I think.
Oh, I don't know. So
in the chat, anyone know? Oh, yeah. Crispy Silicon, yeah. I've seen this as a meme, but I've not seen it for real. Windows 95 on floppy. Oh, that's bad. I mean, I thought it was bad for the Secrets of Monkey Island 2 on the Amiga was 10 or 12 discs in size. And that was huge. But yeah, Windows 95 is a huge program compared to that. You get floppy elbow, like tennis elbow, from changing disc, wouldn't you? Wow. Yeah. You get halfway it's corrupt. Yeah, one of your discs has got a scratch or some dirt. Yeah. Overclocking Archimedes A310s. 36 megahertz ARM free. Speed Demon. Nice. And there we go. So DOS 622 and then 3 or 5. Yeah. Wow. We have basically turned this into a retro computing show tonight, which is great. I like that. Considering I've got 3 retro computers just around me. I've got 3 Commodores, which are 40 years old in this room. They're just in drawers, just out of sight. But very cool. But we'll go back to what we're actually here for, which is talking about your code. So I'm going to put the banner on the screen now so everyone can go and have a look at the code. And if you want to look in the chat, there's a link in the chat for where you can get this code, have a play with it and have a read. Have a go. Put some suggestions to Pieter about how it can be improved, how you can change it, what bugs you found, make it better. Because this is an exceptional tool which is going to help everyone who's in the Pi community to benchmark and test their Pis so we can get the best speeds out of it and the best performance. So give it a look, give it a go. So Pieter, thanks for coming on. As I know it is very early in the morning for you over there. You're in the future. So thanks for coming on.
Thank you very much. Yeah, thank you very much for inviting me. This was lovely.
Oh, brilliant! Thank you. So we're going to be back next week. Our guest next week is Cian Ryan. Cian's going to be talking about how he made custom Raspberry Pi arcade cabinets for a recent client project. They're exceptionally well made, and he's going to detail all the parts about how he did it, the electronics, the woodworking, everything, so we can understand how he did this great project. But we're back next week at the same time, and I'll see you then. Thanks.